World of Tanks was seriously rehauled last year. With Update 1.0, the game moved to the new core engine and upgraded its graphics to AAA standards. In Update 1.4, we're launching full support for multi-threading. Some of you may have experienced the new level of performance on the common test. In order to move on, we must drop old technology. So today, we will talk about Windows XP and DirectX 9.
Windows XP launched in 2001, almost 18 years ago. The last service pack was released in 2008. Microsoft themselves stopped supporting this operating system in 2014. This is why you can't find new video card drivers for Windows XP. World of Tanks players know this, and the number of players using Windows XP decreases rapidly each year.
Starting late this spring, we can't guarantee a stable performance of World of Tanks on PCs running Windows XP and Windows Vista. There are several reasons why. What does moving from Windows XP give to a player? First of all, better security. Many vulnerabilities were found in operating systems over the last couple of years. These vulnerabilities will be fixed in those operating systems that are currently actively supported. However, they will never be fixed in Windows XP. Secondly, you will have better client and battle loading speeds after updating your operating system. Some Windows XP restrictions didn't allow for fast data loading rates from hard drives. New OSs don't have such restrictions. And finally, what's most important, our game will be able to use your system's RAM more efficiently.
Let's take a PC based on 32-bit Windows XP with 8 GB of RAM as an example. As is known, 32-bit operating systems can't address or see more than 4 GB of RAM. So, more than half of those 8 GB are simply not used by the system. But that's not all. Windows XP restricts RAM usage to 2 GB per process, which includes our game. Doesn't sound that bad. That's where the DirectX 9 legacy shows up. It uses part of the RAM allocated for the WOT process for storing video assets, such as textures and models. So, out of 2 GB, the game uses about 1.5. Let's take the same PC, but running Windows 7 32-bit. The system still uses only half of the available RAM. It also allocates no more than 2 GB to our game. However, Windows 7 supports DirectX 10 and consequently VRAM virtualization. This allows for allocating RAM for video assets in such a way so that the game could fully use its 2 GB. Now the third option, the one we recommend, a 64-bit operating system. The game has a lot more room to breathe. The system uses all of your RAM. 4 GB can easily be allocated for a 32-bit game client. And there is even more room for video assets.
If we're talking about game performance, we shouldn't forget about DirectX. This technology first appeared back in 1995. It's changed a lot over the last 24 years. Starting from a simple function of outputting the picture processed by the CPU to the monitor, and ending with a full-scale integrated solution that allows to program modern graphics processing units. The difference between DirectX 9 and DirectX 10 is considerable. Version 10 of the technology supports a number of software and hardware optimizations. A more efficient data storage format was implemented. They are smaller in size, which means they save storage space, and it makes loading them into the GPU local memory faster. Extended GPU instructions were introduced, which allows for more operations per cycle. Compute shaders were supported. Now the GPU is not only fit to perform graphics calculations, but also general calculations, such as physics, for example. And the most important feature was unified shader architecture.
Outputting graphics to the monitor was just the beginning. Let's take a look at the most important change introduced by switching from DirectX 9 to DirectX 10, working with pixel and vertex shaders. In the age of DirectX 9, special dedicated computing units in the video card's GPU were there for this task. Vertex unit processed vertices that were building the scene geometry. The pixel shader dealt with displaying a pixel's color on the screen. In other words, it painted the geometry. The GPU had a certain number of pixel and vertex units. Depending on what was happening in the 3D scene, the pixel and vertex units could be loaded unevenly. For example, when a landscape with many vertex calculations and little painting load is drawn, pixel units are basically idle and the vertex units are almost fully loaded. And the other way around, when an explosion with many particles and smoke must be drawn on screen, pixel units start to boil and the vertex ones are chilling out. It leads to a part of functional units simply being idle. It's not efficient. Starting from video cards of the GeForce 8800 and Radeon HD 2000 series, as well as Intel GMA X3000 integrated graphics, that all had DirectX 10 support, a unified shader architecture was implemented. Since then, video card units can perform any type of shader task. GPU resources are fully used all the time. No computational unit is idle.
It's important to note that many technologies are simply impossible with DirectX 9 and Windows XP. Texture arrays and HDR textures, to name a few. We can use tessellation for a greater number of subsystems of our graphics engine. We can use compute shaders to create more advanced post effects and optimize the existing ones. We can use more effective object clipping algorithms for rendering, which will benefit all our players. One of the great examples is an advanced particle system. Take snow, for example. Not only there's more of it now, but every snowflake behaves according to the laws of physics, meaning it reacts to wind and goes around obstacles. And what's most important, this technology would be effectively impossible with DirectX 9.
We are dedicated to improving World of Tanks for everyone by taking advantage of technological advancements. With every update, we hope you will enjoy a greater experience.